Hello, my friends. In the last video, we have introduced the concept of Thevenin and Norton analysis. And we also ran through the Thevenin procedures. We have not done anything on Norton analysis. Today, we are going to go through the Norton analysis for the same circuit. So this was the circuit that we have left from last time. We are going to find the Norton equivalent circuits. So the procedure of Norton is very similar to Thevenin analysis, with the exception that, right, instead of shorting the circuit at the output, right, instead of opening the circuit in the output, we are going to sort it. So the first step is short circuit the output. The output so we are going to do this. And from here, we will find the current. And this current is going to be so-called Norton current. So the second step is, right, find the current at the output. And this current is the Norton current. So if I'm going to find the current here, then this will be IN. Now the way how we find the Norton current is very tricky, right? There are many ways to do that. I personally prefer the lousy way. Now, instead of finding the Norton current first, I'm going to work out the voltage at this point first, and then eventually I will use the voltage to work out the current. So now the voltage here can be evaluated using the voltage divider method. You have the parallel resistor here, and you have a 3 ohm resistor in series with this parallel circuit. So we can say that 12 ohm, 12 volt, and then the output is going to be the voltage Vx is going to be 7 in parallel with 6, and then 7 in parallel with 6 plus 3. And then we are going to find the current. The IN is going to be Vx divided by 7. This means 12, 7, and then times 1/7. And this will give you, this will end you up with, let's see, I need to calculate it. And then divided by 7. So I got the current here, uh, 0.889 ampere. It makes sense. The next step is open circuit the output again. Open circuit the output again. And then, by the way, so zero all the sources, all the sources, all the independent sources. So in this case, what we are going to do is to open circuit here, and then zero the source. This means we are going to short circuit it. Short circuit it will produce 0 volts here. And then we are going to measure the Norton. Measure, yeah, I shouldn't say measure. Find the output impedance. This impedance is Norton impedance. So in this case, the Norton impedance is going to be let's see, I need to check. It is going to be 7 plus 3 in parallel with 6. So this will end you up with 9 ohm, same as before. Norton impedance is exactly the same as Thevenin impedance. So in other words, right, I have already got the answer. The only thing that I have not got is the equivalent circuit representation. How we can mount the circuit. So the answer is going to be to be like this. And the current source, Norton current source will be connected in parallel with a Norton resistance. Sorry, Norton impedance. In this case, 9 ohm here. And the current here should be 0.8889 ampere. So this is the answer. This is the answer for this question. This is the answer. So if you have any question, you just leave this to the comment sections, and I will be able to deal with you later. Thank you.